Next topic is linearly dependent and linearly independent set or vectors. Linearly independent vectors or linearly dependent vectors or linearly dependent and independent set. So let V be a vector space and V1, V2, Vn, write a bar or without bar. Let V1 bar, V2 bar, Vn bar or V1, V2, Vn be vectors in V. If there exists a scalars k1, k2, kn, not all 0, such that k1 v1 plus k2 v2 plus kn vn is equal to 0, then v1, v2, vn are called linearly dependent vectors. Linearly dependent vectors. And if we form the set of v1, v2, vn, suppose S is the set of v1, v2, vn, then if there exists a scalars k1, k2, kn, not all 0. This word is important. These words, not all 0. These k1, k2, kn are not all 0. Then but their linear combination with this v1, v2, vn is 0. Then v1, v2, vn are called linearly dependent, or then set S, that is the set of v1, v2, vn is denoted by suppose capital S. Then S is called linearly dependent set. So both the definitions of linearly dependent vectors or linearly dependent set are set. Just prepare the set of this v1, v2, vn and denote it. Suppose yes, then yes is, we say last sentence that yes is linearly dependent set. So next is, if this k1, k2, kn all are 0, then we say the set is, this set or these vectors v1, v2, vn are linearly independent. So the next definition of linearly independent vectors, let V be a vector space and v1, v2, vn be vectors in V. If the equation k1, v1 plus k2, v2 plus kn, vn is equal to 0, where k1, k2, kn are scalars, has only one solution, k1 is equal to 0, k2 is equal to 0, and kn is equal to 0. That is, all these k1, k2, kn are 0, then v1, v2, vn are called linearly independent vectors, or the set of these vectors v1, v2, vn is called linearly independent set. So if this equation k1, v1 plus k2, v2 plus kn, vn, if these k1, k2, kn all are not equal to 0, then these v1, v2, vn are called linearly dependent. And if all these k1, k2, kn are 0, then v1, v2, vn are called linearly independent vectors. So example, determine whether this set, these equation number 1 and equation problem number 2 are linearly dependent or linearly independent. So example, answer of example number 1. So we have to determine whether these three vectors are linearly dependent or independent. So there are three vectors, so take three scalars. Let k1, k2, k3 be scalars such that k1 v1 plus k2 v2 plus k3 v3 is equal to 0. Suppose these three vectors are denoted by v1, v2 and v3 bar. Okay, then the first sentence is what? We have to determine these three vectors are linearly dependent or independent. So take three scalars, k1, k2, k3. If there are four vectors to determine the linearly dependent or independent vectors, then take four scalars, k1, k2, k3, k4. So here are three vectors. So take three scalars. Let k1, k2, k3 be scalars such that k1 v1 plus k2 v2 plus k3 v3 is equal to 0. So write v1 as 1, 1, 1, v2 as 0, 1, 1, and v3 as 0, 1, minus 1 is equal to 0 bar. The 0 bar is what? Is the 0 vector of this R3. These three are the element of R3, R raised to 3, the vector space R raised to 3. So its 0 is what? 0, 0, 0, 3 tuple 0, 0, 0 is the 0 of that R3. Then multiplying by k1, multiply by k2, multiply by k3. Okay, by using, this is by using the scalar definition of scalar multiplication in R3. Then addition of three vectors, this. So by using the definition of addition, what we have? K1 plus 0 plus 0. So K1 comma, write comma, K1 plus K2 plus K3 comma. Don't write this bracket, just write one single bracket. Then K1 comma, K1 plus K2 plus K3 comma, K1 plus K2 minus K3 is equal to 0, 0, 0, 3 tuple. And then compare what we have. K1 is equal to 0. The second equation is K1 plus K2 plus K3 is equal to 0. And the third equation, K1 plus K2 minus K3 is equal to 0. Now we have to solve this system and we have to find the values of K1, K2, K3. If all these K1, K2, K3 are equal to 0, then this set or these three vectors are linearly independent. If K1, after solving this system, if K1 is 0, K2 is 0 and K3 is 0, then we say the given three vectors, these three vectors are linearly independent. And if we have out of these three, K1, K2, K3, at least one is not equal to 0, then we say these three vectors are linearly dependent. So now we have to solve this system. Again, we have to use the Gauss elimination method to solve the system. So write augmented matrix. One coefficient of K1 is 1, coefficient of K2 is 0, coefficient of K3 is 0 is equal to 0. Then 1, 1, 1, 0, 1, 1, minus 1, 0. Now we have to reduce this matrix to echelon form. So reduce this two element to 0. So R2 minus R1, R3 minus R1. First row as it is, second row 1 minus 0 is 1, 1 minus 0 is 1, 0 minus 0 is 1. So we have this third row. Now we have to reduce this element to 1. It is 1. So you reduce this element to 0. So it is 1. So R3 minus R2. So first row as it is, second row as it is, 0 minus 0 is 0, 1 minus 1 is 0, minus 1 minus 1 is minus 2, 0 minus 0 is 0. Now we have to reduce this minus to 1. So minus 1 by 2 R3, minus 1 by 2 R3. That is multiply the third row by minus 1 R. So 1 0 0. The first second row as it is. Third row is what? 0 0 1 0. This is an echelon form, or it's called row echelon form. And so, and this system is a homogeneous system. So a homogeneous system is always consistent. So there is no case of inconsistent. That is, don't write the rank of A and rank of AB. In every case of homogeneous system, why this is homogeneous system? Because all these equal to 0, are equal to 0. So in the case of homogeneous system, the system is not inconsistent in any if it is any system, homogeneous system, then it is then the system is always consistent. Homogeneous system is always consistent. So there is no case that homogeneous system is inconsistent. So no need to write the rank of A and rank of AB. But if you write rank of A is 3, rank of AB is also 3, because this whole is the echelon form of the matrix AB, and these first three columns are the echelon form of the matrix A. And rank of A is 3, rank of AB is 3. The system is consistent. So rewrite the equation. K1 is equal to 0. K2 plus K3 is equal to 0, second equation, and the last equation K3 is equal to 0. So substitute K3 is equal to 0 in above equation. We have K2 is 0. So K1 is 0, K2 is 0, and K3 is 0. And therefore V1, V2, V3, that is the given three vectors. These three vectors are linearly independent. If we have one of them is non-zero, then we say the system is, then we say that the given vectors are linearly dependent. But we have all these K1, K2, K3 are 0, and therefore V1, V2, V3, these three vectors are linearly independent. The next problem is, again, we denote these three vectors as a V1 bar, V2 bar, and V3 bar. And now there are three vectors. So take three scalars, let K1, K2, K3 be scalars such that K1 V1 plus K2 V2 plus K3 V3 is equal to 0. Then K1 2 minus 1 3, K2 4 1 2, K3 8 minus 1 8 is equal to 0 bar. That is 0 0 0 or 3 tuple. 0. These V1, V2, V3 are the vectors of R raised to 3. So it 0 is what? 0 0 0, 3 tuple 0 0 0. And then apply the definition of scalar multiplication. We have this. Then apply the definition of addition. We have the 2K1 plus 4K2 plus 8K3 is equal to this vector. Then comma minus K1 plus K2 minus K3, and their third vector is 3K1 plus 2K2 plus 8K3 is equal to 0 0 0. Write that step. And then equating the LHS and RHS, we have 2K1 plus 4K2 plus 3K3 8K3 is equal to 0. Then minus K1 plus K2 minus K3 is equal to 0, and then 3K1 plus 2K2 plus 8K3 is equal to 0. So write the one more step. Write the addition of these three is equal to 0 0 0, and then write this step. Now we have to solve this system. So write the augmented matrix. So 2 4 8 0 minus 1 1 minus 1 0 3 2 8 0. Okay, and we have to reduce this matrix to echelon form. So minus 1 R2, that is the interchange the first and second row, and then change the sign of first row. So we have 1 minus 1 plus 1 0 as the first row, 2480 and 3280. Then we have to reduce this 2 and 3 to 0. So R2 minus 2 R1 by using this one, R2 minus 2 R1 and R3 minus 3 R1. So first row as it is, second row is this. So minus 2 and plus 2 and plus 4 are is 6. Then minus 2 plus 8 is 6, 0, 0. Then 0. Then minus 3 into minus 1 is plus 3 plus 2, 5. Then minus 3 and plus 8, 5, 0. Then we have to reduce this 6 to 1. So first write the step, apply the transformation 1 by 6 R2, and then we have this 1 by 6 R2, 1 by 6 R2. Okay, so our R2 minus R3, R2 minus R3. In both cases, we have this. Either write this transformation or 1 by 6 R2. We have this, and then we have to reduce this 5 to 0. So R3 minus 5 R2. By using this one, we have to reduce this 5 to 0. So first row and second row as it is, the third row here 0. We have as well as here 0 because minus 5 plus 5 0, and this is an echelon form. And so rewrite the equation. So in this case also the system is consistent. So rank of AB is 2, rank of A is also 2, and the rank of A is equal to rank of AB and is equal to 2, and therefore the system is always consistent. The system is homogeneous system is always consistent. There are only two cases. Either this system has unique solution or this system has infinitely many solutions. If the system, when the system has the unique solution, then all the values of unknowns K1, K2, K3 are 0, like this. And when the system has unique solution, if rank of A is equal to rank of AB is equal to number of unknowns. So if you observe this example, rank of A is 3, rank of AB is 3, and the number of unknowns in the system are 3. And in this case, the system has unique solution. We know that. And if the rank of A, in this case, rank of A is 2, rank of AB is 2, and is strictly less than number of unknowns because number of unknowns are 3. And so in this case, the system is consistent, but the system has infinitely many solutions. So rewrite the equation. What we have, K1 minus K2 plus K3 is equal to 0, and K2 plus K3 is equal to 0. So these are the two equations, and there are 3 unknowns. So assign one unknown. So suppose K3 is minus T. Suppose K3 is minus T or K3 is T. We assign one unknown. Suppose K2 is, we assume K3 is T or K2 is T. So if we assume K2 is T, then K3 is minus T. Or we can assume as a K2, K3 as T, and then we have K2 as minus T. We assign out of this K2 and K3 one unknown. So suppose K3 is T or suppose K2 is T. So suppose K2 is T, then K3 is minus T, and substitute the values of K2 and K3. We have K1 is minus 2T, and therefore the matrix, the solution is what? K1, K2, K3. The line column matrix is equal to 2T, T minus T, as take T common. So 2, 1 and minus 1. These are the write here T before this matrix. Write T here. So take T as common, and so K1, K2, Kn are not all 0. What is the case? This K1, K2, K3 are not all 0, because if you take T as a value of T as any real number, okay, if you take T as 1, then we have the value of K3 as minus 1, K2 as 1, and K1 is minus 2. If we take T as 2, then K3 is minus 2, K2 is 2, and K1 is minus 4. That is, these K1, K2, Kn are not all 0. Okay, someone says that take T as 0. If we take T as 0, then K1, K2, K3 is 0. But this K1, we have to take this T as any real number. So one of the solution of this system is what? It's obviously K1 is equal to 0, K2 is equal to 0, and K3 is equal to 0. But this system has not only that solution. This system has 0, that is K1 is 0, K2 is 0, K3 is 0. This is one of the solution of this system. But instead of this, the system has another solution, non-zero solutions. So this, if you observe the definition of linearly dependent and independent. So what is the case? That if the system K1 V1 plus K2 V2 plus Kn Vn is equal to 0 has only one solution, K1 is equal to 0, K2 is equal to 0, and Kn is equal to 0. But this system does not have only one solution, that K1 is equal to 0, K2 is equal to 0, and K3 is equal to 0. This system has the solution K1 is equal to 0, K2 is equal to 0, K3 is equal to 0. But instead of this, the system has also non-zero solution. That if we take T as 1 or 2 or 3, we get the non-zero solution. And therefore, K1, K2, K3 are not all 0. And therefore, the given vectors are linearly dependent. So these vectors are linearly dependent. So these two problems indicate the procedure to show the set is linearly dependent and set is linearly independent. The procedure of answer is set. That is, in the first example, the set is linearly independent, and in the second example, the set is linearly dependent, but the procedure is same. That is, take three scalars K1, K2, K3 such that K1 V1 plus K2 V2 plus K3 V3 is equal to 0. Solve the system and find the values of K1, K2, K3. If all K1, K2, K3 are equal to 0, in the first case we observe, then the vectors V1, V2, V3 are linearly independent. And if the K1, K2, K3 are not all 0, then the given vectors are linearly, that is the given vectors V1, V2, V3 are linearly dependent. So these two examples gives the procedure to how to show the set is linearly dependent and set is linearly independent. Okay, let S is equal to E1, E2, E1 plus E2, where E1 is 1, 0, 0 and E2 is 0, 1, 0. Then find ELS and give geometrical interpretation of ELS. This is the problem of actually previous topic, that is the linear span. So E1 plus E2 is the combination of E1 and E2. It is 1 E1 plus 1 E2. And therefore, L of E1, E2, E1 plus E2 is equal to L of E1, E2. Because this E1 plus E2 is linear combination of E1 and E2. And therefore, it always belongs to L of E1, E2. What is L of E1, E2? It is a set of all linear combinations. And so, obviously, E1 plus E2 belongs to L of E1 plus E2. So, L of E1, E2, E1 plus E2 is L of E1, E2. And L of E1, E2 is what? K1, E1 plus K2, E2, so that K1, K2 belongs to R. That is, what is L of E1, E2? It is the set of all linear combination of E1 and E2. That is K1, E1 plus K2, E2, so that K1, K2 belongs to R. This is by using the definition of a linear span. And E1 is 1, 0, 0, E2 is 0, 1, 0, K1, K2 belongs to R. Apply the definition of scalar multiplication. We have this K1, 0, 0, 0, K2, 0. And then apply the definition of addition. So we have K1, comma K2, comma 0 plus 0 is 0, and K1, K2 belongs to R. So this is find L of S. So this is L of S. This is the L of S. K1 is a set of a triplet K1, K2, 0. Right, round bracket here, round bracket complete, such that K1, K2 belongs to R, and then curly bracket complete. And this is XY plane. K1, K2, 0, set of K1, K2, 0. This is the XY plane. So give geometrical interpretation of ELS. So what is the geometrical interpretation of ELS? This ELS is the XY plane. So next example of linearly dependent independence type. Determine whether the set, this is the set of three vectors, and obviously 2, 1, 0, 3 is 4 tuple. So these three elements are the elements of R raised to 4. The vector space R raised to 4. Okay, and we have to determine whether this set contains three vectors from R raised to 4 is linearly dependent or independent. So there are three vectors denote, suppose V1, V2, V3 bar, right? V1 bar, V2 bar, and V3 bar, or just V1, V2, V3. And now there are three vectors. So in order to determine these vectors are linearly dependent and independent, we have to take three scalars. So write the sentence: let K1, K2, K3 be scalars such that K1 V1 plus K2 V2 plus K3 V3 is equal to 0 bar. Write that sentence, and then write V1 as 2, 1, 0, 3, V2 as this vector, V3 as this, and 0 bar is 0, 0, 0. So first write this sentence, that let K1, K2, K3 be scalars such that K1 V1 plus K2 V2 plus K3 V3 is equal to 0 bar. And then write this statement, this sentence, this equation, that K1 into V1, substitute V1, V2, V3, and 0 bar is 0, 0, 0, 4 tuple 0. And then apply the definition of scalar multiplication. We have this, and then add these three vectors. So write one more step here, right? In round bracket, 2K1 plus 3K2 minus K3, comma K1 minus K2 plus 0, that is K1 minus K2, comma, 5K2 plus 2K3, comma, 3K1 plus 2K2 plus K3. And then is equal to 0, 0, 0. And then comparing the LHS and RHS, we have 2K1 plus 3K2 plus minus K3 is equal to 0. Then K1 minus K2 is 0. And the third equation is 5K2 plus 2K3 is equal to 0. And the last equation 3K1 plus 2K2 plus K3 is equal to 0. So now we have to solve this system and we have to find the values of K1, K2, K3. And all these values are equal to 0. Then we say the given three vectors or the set given this set is linearly independent. And if out of this K1, K2, K3, at least one is non-zero, then we say these three vectors or this set is linearly dependent. So now we have to solve this system. So form the augmented matrix 2, 3, minus 1, 0, 1, 1, 1, minus 1, 0, 0, then 0, 5, 2, 0, 3, 2, 1, 0. So in order to reduce this matrix to echelon form, so we have to reduce this 2 as a 1. So interchange first and second row. We have this matrix. Then we have to reduce this 2 and 3 to 0. So R2 minus 2R1 and R4. This 3 is in the fourth column, fourth row. So R4 minus 3 R1. So first row as it is, second row as it this, third row as this, fourth row as this after calculation. Then we have to reduce this 5 to 1. So just apply 1 by 5 R2 multiplied second row by 1 by 5. So we have 1 minus 1 by 5, 0. The remaining row as it is. Then we have to reduce this 5 and this 5 to 0. So R3 minus 5 R2 and R4 minus 5 R2. So we have this first, second row as it is. The third row is this. Now we have to reduce this 3 to 1. So 1 by 3 R3. So we have 1 at this place. The remaining rows as it is. Then we have to reduce this 2 to 0. So R4 minus 2 R3 by using this one. So we have the first row as it is, second, third row as it is, and the last row 0, 0, 0, 0. And so what is the rank of A? Rank of A is 3 and rank of AB is also 3 and the number of unknowns are 3 and also the system has unique solution. And obviously if the system has unique solution, this is the homogeneous system, and if the system has unique solution, then all the values of all the unknowns are equal to 0. In the case of homogeneous system, if the system has unique solution, so when the system has in unique solution, either it is homogeneous or non-homogeneous. So if the rank of A, rank of AB both are equal and is equal to number of unknowns, then the system has unique solution. And if the rank of A is equal to rank of AB is strictly less than number of unknowns, in that case the system has infinitely many solutions. But in this case, rank of A is 3, rank of AB is 3, is equal to number of unknowns are also 3, and therefore the system has unique solution. And how you can find the solution? So rewrite the equation. So K1 plus K2 is equal to 0, K2 minus 1 by 5, K3 is equal to 0, and last equation K3 is equal to 0. So K3 is equal to 0, substitute K3 is equal to 0 in above equation. We have K2 is 0, and substitute K2 as 0, we have K1 is 0. So K1 is 0, K2 is 0, K3 is 0, and therefore the given three vectors V1, V2, V3 are linearly independent, right? Independent, linearly independent. Or we say the set, the given set, this set of three vectors is linearly independent. When the set is linearly dependent, if K1, K2, K3 are not all 0, but here K3, K1, K2, K3 are all are equal to 0, and therefore the given set is linearly independent, right? Linearly independent. Then we have to show these two vectors are linearly depends on in R2. In R2. So there are two vectors. So take first sentence, I take two scalars. Let K1 and K2 be scalars like that. K1 V1 plus K2 V2 is equal to 0 bar. So V1 is 1 minus 2, V2 is minus 5, 10, and 0 bar as 0, 0. So apply the definition of scalar multiplication and apply the definition of addition. We have in round bracket K1 minus 5K2, comma, minus 2K1 plus 10K2 in round bracket, right? In round bracket is equal to 0, 0, order pair 0, 0. And then compare LHS and RHS. We have K1 minus 5K2 is equal to 0, minus 2K1 plus 10K2 is equal to 0. Then we have to solve this system and we have to find the values of K1 and K2. So form the augmented matrix. This is the augmented matrix 1 minus 5, 0, minus 2 10 0. Now we have to reduce this minus 2 to 0. So R2 plus 2 R1. So we have this, and all the remaining elements are 0. So this is an echelon form. This is an echelon form. And so if you find the rank of A is 1, rank of AB is 1, so system is consistent and is strictly less than number of unknowns. Number of unknowns are 2, and the rank of A is equal to rank of AB is equal to 1. It is strictly less than number of unknowns, and the system has infinitely many solutions. And if once the system, homogeneous system, has infinitely many solution, means the system has non-zero solution. That is, these K1, K2, K3, K4 are not all 0. So rewrite the equation. So what is the equation? K1 minus 5K2 is equal to 0. So there are one equation and two unknowns. So assign 2 minus 1 is equal to 1 unknown. So suppose assign K2 is equal to T, because unknowns are 2, equation is 1. So 2 minus 1, that is 1 is the difference. So we have to assign 1 unknown. So suppose K2 is T, and therefore T is any real number where T belongs to R. Then K1 is 5K2, that is 5T, and therefore hence K1, K2, Kn are K1, K2 are not both 0, not all 0, because if you take T as 1, then K2 is 1 and K1 is 5. So we have the non-zero solution, and therefore K1, K2 are not both 0, and therefore the given vectors are linearly dependent. The given vectors are linearly dependent. So these are some examples of linearly dependent and independent vectors. So we will see the remaining examples uh, in the next lecture of linearly dependent and independent vectors. So there are two types of examples. Set is linearly dependent, or set is linearly independent. So if the all scalars are equal to 0, then set is linearly independent, and if at least one of them is not equal to 0, then set is linearly dependent. So we will see the remaining examples in the next lecture, examples of linearly dependent and linearly independent vectors.